The first time the telescopes found it, the sky felt strangely still. For months, 3IATLAS had been a quiet line in orbital tables, a faint stone fragment threading its way toward the inner sun along a path that seemed almost boring in its predictability. Astronomers tagged it, logged it, and moved on, trusting that gravity and ice would do exactly what gravity and ice always do. In control rooms scattered across the planet, monitors glowed with pale trajectories, smooth light curves, and projections that drifted forward like calm, obedient rivers of data. The expectation was simple, elegant and reassuring, a familiar story repeated countless times before. The object would brighten near perihelion, shed dust and frozen gases, then fade again into the dark as it left the warmth of the sun behind. Night after night, telescopes followed that faint mote of reflected light, watching the magnitude creep upward as 3IATLAS slipped deeper into the zodiacal dust, into the softly glowing plain where comets usually bloom. The air around the observatories felt thin and quiet, the hum of instruments and the occasional murmur between colleagues the only sounds cutting through the darkness. Outside, the sky arched overhead like a vast listening dome, collecting the pale photons that had crossed millions of kilometers to land on a single polished mirror. Then the first models finished rendering, and something inside those clean graphs refused to sit still. The light curve, instead of rising in a smooth, predictable swell, bent gently away from the projections, like a river pulling against its mapped banks. The numbers were not chaotic, but they were not obedient either, and the subtle deviation tugged at the edge of every seasoned eye that looked at it. At first, they blamed calibration, as they always do. A misaligned sensor here, a temperature drift there, perhaps a faint atmospheric distortion layered invisibly over the data. Small corrections were applied in quiet, practiced motions, the kind of routine adjustments that usually straighten the universe back into place. But when the adjusted models finished, the curve still bent the wrong way. The rise was there, yes, but it was too smooth in one region, too flat in another, like a heartbeat that missed a beat yet insisted on calling itself healthy. In room after room, across continents and time zones, different teams saw the same gentle wrongness emerge from the noise. They held printouts up to the light, eyes tracing the faint divergence between prediction and reality, a thin gap where something unaccounted for had slipped in. A few shrugged and moved forward, telling themselves that the discrepancy sat well within the margins of error. Others felt a small, persistent knot tighten in their chests, the feeling that the universe had just cleared its throat in the middle of a supposedly simple story. Outside, the object continued to glide through space with silent composure, its stone fragment body turning slowly in a sea of dust and golden haze. The sun grew larger in its sky, a blazing disk that should have dictated every shift in brightness, every glint off every fracture on its surface. And yet the brightness rose not quite as expected, not quite as modelled, as if something between the stone and the sunlight was quietly negotiating its own terms. In the late hours, when most of the world slept, astronomers leaned over their monitors under dim red lights, the glow painting soft shadows under tired eyes. They ran simulations again and again, feeding in different assumptions about dust, rotation and reflectivity, hoping to pin the curve back into place. Each attempt came closer, but none landed perfectly on the real data, as if the object always held itself half a step away from complete understanding. Some began to talk about it in low voices, not as a comet, not as an asteroid, but simply as it, a nameless presence moving through the inner system with an attitude that felt almost reserved. The wrongness was still small, still deniable, but it clung to the graphs like a faint aftertaste, too subtle to describe yet impossible to ignore. In their notes they wrote about anomalous curvature, about residuals and unmodelled parameters, never once using the language their hearts whispered in the quietest moments. Above them, the sky remained silent and deep, dark bands of interstellar space wrapped around the bright line of the ecliptic. Somewhere within that luminous plane, 3IATLAS turned its cracked stone skin toward the sun, reflecting light in a way that did not fully belong to dust or ice. The universe had not shouted, not yet, but it had tilted its head slightly, as if listening to itself through this drifting fragment. And so the nights went on, one after another, with telescopes staring and computers calculating, while an almost invisible deviation in a single light curve opened the first quiet door in the minds of those who watched. They did not know it yet, but the story of 3IATLAS had already stepped off the familiar path, leaving them standing at the edge of a question they had no words for. The first flicker arrived as nothing more than a nuisance in the data, a tiny spike buried deep inside the grey breathing of background noise. It appeared as a momentary rise in brightness so small that software filters erased it without hesitation, sweeping it away with the rest of the cosmic static. For a while, no one noticed that the erasure kept happening in the same place, at the same interval, like a skipped heartbeat hidden beneath the hum of the universe. In a dim control room, a single analyst lingered long past his scheduled shift, the glow of the monitors painting his face in tones of pale blue and amber. He had run the observation logs 3 times already, watching the residuals on 3IATLAS climb and fall in their strange shallow arcs. Tonight, something in the graphs made him slow down, zooming in on the regions of noise that everyone else had trusted the algorithms to ignore. Between the familiar drifts of static, he found it, a faint tooth of light rising where there should have been nothing but drift and randomness. It was not large enough to be dramatic, not clean enough to be obvious, just a soft, precise spike that returned like a tired echo each time he rewound the data. He checked his processing pipeline, then the raw files, running diagnostics on the detectors with the quiet patience born from long nights under indifferent skies. Each test returned clean, each instrument reported no fault, and yet the tiny spike remained, repeating from the direction of 3IATLAS like a shy hand raised in the back of a crowded room. He marked it, once, then twice, and slowly the timing between the spikes began to stand out, a regular space where randomness should have ruled. It was too early to call it a pattern, but it did not feel like an accident either. Across the world, in another observatory wrapped in dry desert air and wind-whispered silence, another team noticed a similar annoyance in their own data streams. Their instruments, peering at the same object from a different corner of the planet, caught the same faint teeth of light rising from the noise floor in the same narrow window of time. At first, they dismissed it, chalking it up to software quirks and the occasional misbehavior of sensitive electronics pushed to their limits. But when the logs were lined up carefully, when the timestamps were compared and corrected for distance, delay and rotation, something uncanny emerged from the numbers. The spikes lined up almost perfectly, tiny pulses of brightness appearing in separate data sets at the same intervals, with the same soft resilience against the filters trying to erase them. The noise, it seemed, was not noisy at all. Emails began to cross oceans in quiet urgency, graphs attached with faintly shaking hands and short, cautious messages. "Have you seen this pattern? Does your noise do this too?" The replies came back with images circled in red, small spikes highlighted against seas of grey, each one rising like a heartbeat too regular to belong to chance. Together they recalibrated, rebuilt their filters, and reran their pipelines using stricter thresholds. The spikes survived every adjustment, every attempt to push them back into the dark, as though the universe itself refused to let them go. The background static still boiled and shimmered around them, but the spikes rose with the same patient certainty each time the object rotated into view. In the soft-lit observatories, the atmosphere shifted almost imperceptibly, a new tension humming beneath the normal routines. Conversations grew quieter, more deliberate, as the teams began to use different words in private, words like pulse and beat, whispered with a mix of awe and unease. Officially, they still called it a possible artifact, a candidate anomaly, something to be watched but not yet trusted. Unofficially, in the hush between keystrokes and the low murmur of cooling fans, they allowed themselves a different thought. If the spikes were real, then something out near 3IATLAS was gently tapping the fabric of the visible universe, pressing a repeating mark into the light that reached their mirrors. It was too faint to be a beacon, too subtle to be a shout, but it was far too clean to be dismissed outright. For the first time, they began to talk not just about what the object was, but about what it might be doing, as though the stone fragment gliding through space had quietly joined the list of things that act, not just things that are. Under the weight of that possibility, the noise no longer sounded like noise at all. It sounded like a curtain rustling just before something steps through. The number arrived like a quiet verdict. Simple and undeniable. 11.2 seconds. That was the interval at which the faint spikes returned, ticking upward from the flux like the steady beat of a patient metronome hiding in the heart of the data. In Hawaii, the analyst who first grew suspicious watched the timestamps align in a perfect ladder of moments, each spike perched atop a precise gap that never wavered. He recalculated with different time standards, corrected for light travel, orbital motion, and signal delays. Yet the spacing held firm, 11.2 seconds, again and again, as if the universe had quietly installed a clock in the path of 3IATLAS. On the other side of the world, in the thin, cold air of the Chilean desert, another team reached the same conclusion hours later. Their telescopes, tuned through dry skies and razor-sharp seeing, recorded the same rhythm, each flicker arriving exactly where it should if the timing were real. When their data sets were combined, the spikes locked together with unnerving precision, overlapping like footprints pressed into the same trail from different directions. Instrument error melted away under the harsh light of cross-checks. Local interference could not replicate itself across thousands of kilometers, through different machines, under different atmospheric conditions. The pulse did not belong to any single detector, any single cable, any single software system. It belonged to the sky. Meetings grew longer and quieter as the implications settled in. In conference calls lit by the glow of shared screens, scientists traced the spikes with digital pens, their voices low and measured as they walked one another through the evidence. Someone suggested a rotating body with a reflective patch, a natural lighthouse effect created by an uneven surface spinning under sunlight. The idea held for a moment, comforting in its familiarity, until simulations showed that such a mechanism would drift over time, wobbling as the rotation shifted and the outgassing jets tugged at the irregular stone. The real signal didn't drift at all. It held its tempo like a musician unwilling to miss a single beat. 11.2 seconds. Over minutes and hours and days, the rhythm continued, steady as a heartbeat and just as haunting. The pulse did not care about human sleep cycles or the turning of the earth beneath the observatories that watched it. In the quiet corridors between labs and offices, a new phrase began to circulate, spoken softly, almost apologetically. On purpose. The idea that something out there might be blinking on purpose felt too large to say loudly, as if raising one's voice might cause reality to snap back into something smaller and safer. Official memos were more cautious, filled with phrases like non-stochastic behavior and statistically significant periodicity, but beneath the clinical language, hearts beat faster. Some feared ridicule if they pushed the implication too hard. Others feared what it would mean if the implication was true. Late at night, when the control rooms thinned and only a handful of watchers remained, a few of them converted the light curve into sound, letting the data translate into a simple tick. What came through the speakers was spare and unadorned. Tick, pause, tick, pause. 11.2 seconds of silence held carefully between each quiet impact of sound. It did not sound like music, or language, or any known pattern of modulation, and yet it did not sound random either. It felt like waiting, like the smallest possible unit of attention being tapped gently against the walls of human understanding. Somewhere far from every telescope, 3IATLAS continued its slow approach, its stone fragment shell drifting through sunlight and shadow, while the pulses rose and fell with unshaken regularity. No one could say what, if anything, was making the object blink, but each new measurement tightened the knot inside the chests of those who watched. Natural processes make noise, stumble and wander. This rhythm did not wander. And as the number 11.2 repeated itself in paper drafts, meeting notes, and restless thoughts, the mystery of 3IATLAS shifted from a curiosity at the edge of the system to something else entirely, something that felt uncomfortably like presence. The first thermal maps looked ordinary enough, bands of colour draped across a rough, distant shape, translating invisible infrared light into something the human eye could understand. Reds and golds traced warmth along the fractured surface of 3IATLAS, while cooler blues fell into the shadows between ridges and broken plates of stone. It was only when the maps were placed side by side in sequence that the ordinary began to unravel. In one frame, a patch near the object's equator shone a little brighter, a soft glow spreading outward like embers beneath thin ash. In the next, that region dimmed while another segment along its spine began to warm instead, the heat shifting location with a grace that felt unsettlingly deliberate. Natural objects absorb and release heat, but they rarely move it around themselves as if by choice. At first, the fluctuations were written off as quirks of measurement, the result of differing angles, exposure times, and instrument sensitivities. Teams recalibrated their detectors, corrected for distance and viewing geometry, and ran the reconstructions again with fresh caution. Yet every refined map told the same quiet story. The warmth on 3IATLAS was not random, it was travelling. The temperature rose in smooth, calm intervals, then fell with equal composure, holding to a rhythm that mirrored the strange stability of the brightness pulses themselves. Heat rippled across the surface in waves, gliding along fracture lines and stone plates with uncanny precision, as though following channels hidden beneath the visible crust. It did not boil or flare like simple outgassing, it flowed. In one observatory, a researcher watched the time sequence unfold, tracing the path of the warmth with the tip of a pen pressed gently against the screen. Her brows furrowed as each glowing patch appeared, swelled, then faded exactly as the next region came alive, like a series of rooms being lit and extinguished in careful order. She checked the model against predicted solar input and found that, even when the object rotated partially into shadow, the internal rhythm continued. The sun was involved, but it was not in control. The object seemed to be making its own choices about where to be warm and where to go cold. In the report she drafted later that night, she called it thermal regulation, then hesitated and softened the phrase to structured variation, the safer language sticking in her throat like dust. As more observatories joined the effort, the picture sharpened. Data from different nights, different instruments, and different vantage points all pointed to the same conclusion. The temperature cycles were consistent, repeating in patterns that geologic and ice could not easily explain. The intervals between peaks remained steady, and the amplitude of the warm pulses stayed within a narrow, disciplined range. In internal meetings, comparisons nudged dangerously close to biological metaphors. Someone suggested the maps looked like breathing, like the slow inhale and exhale of heat across a sleeping body. Another murmured that the flow resembled a cooling system, the way engineered machines move warmth away from vulnerable components. Officially, such language was discouraged, replaced with cautious terms like non-random redistribution and anomalous thermal coherence. Unofficially, in the late hours when the rooms grew quiet and the only sound came from the soft ticking of hard drives and the faint whir of fans, the deeper truth was harder to escape. The object did not just sit in sunlight and respond. It seemed to manage its own response. The thermal pattern tightened as 3IATLAS approached perihelion, the warmth collecting more frequently along specific fractures and along a subtle ridge that ran almost like a spine down its longest axis. As the pulses of heat moved, they began to sync more clearly with the brightness spikes, as if light and warmth were following the same internal script. Each beat of brightness found an echo in the motion of heat inside the stone. In the quiet inner rooms of their minds, some of the scientists already knew what the data implied, even if they refused to let the thought reach their tongues. Regulation meant control. Control meant system. And systems, as they understood them, did not assemble themselves from random rubble and ice drifting helplessly through ancient dark. Whatever lay beneath the fractured skin of 3IATLAS, it was not behaving like a relic. It was behaving like something preparing itself for whatever came next. The attempt to force 3IATLAS back into the category of comet was stubborn and sincere, driven by a deep human need for the universe to remain legible. Teams around the world built models with everything they knew about icy bodies, flung in from the outer dark, feeding in dust jets, irregular rotation, and complicated outgassing patterns. They tried to make chaos sing in 11.2-second intervals, to make randomness mimic a metronome. In simulation after simulation, digital comets tumbled and flared, their brightness curves spiking wildly as volatile pockets burst and spun under the sun's heat. For a frame or two, some models came close, offering fleeting alignments where a lucky jet or a particular angle produced something almost like the observed signal. But the resemblance never lasted. The rhythms fell apart, the curves slipped, and the elegant ticking seen in the real data dissolved into noise. Natural objects, even the most well-behaved among them, refuse to keep time with such clean discipline. They wander, they drift, and their fractures shout in messy, unpredictable flares. 3IATLAS, by contrast, held its pulse like a secret it had no intention of surrendering to chaos. The same was true of the thermal maps. Models of heat diffusion through porous rock and ice insisted that warmth should spread gradually outward from sunlit regions, smearing into cooler zones with no regard for elegance or repetition. Yet the real object channeled its heat in tight, looping patterns, turning warmth on and off in specific regions with a precision that left the simulations looking clumsy and dull. In meeting rooms filled with printouts and projection screens, scientists pinned graphs to walls, laying real and modelled curves side by side. The difference between them was not subtle once you knew where to look. The models stuttered and jittered, full of the rough edges of chance, while the actual data flowed in lines that looked less like accidents and more like intentions. Someone eventually said the quiet part out loud during a late session, the words hanging in the stale air like a weight. No comet does this. The statement was simple, almost gentle, but it drew a sharp stillness across the room, as though everyone present had been waiting for someone else to say it first. Papers in progress began to change tone, their language edging away from comfortable categories and into the uneasy territory of anomaly classification. The phrase non-cometary behaviour appeared more frequently, tucked between careful references to uncertainties and margins of error. The object was still officially unlabelled, but unofficially it no longer fit anywhere they knew how to place it. In the quiet spaces between formal discussions, darker questions surfaced. If 3IATLAS was not behaving like a comet and not behaving like a simple asteroid, then what template could be used to describe it? When you remove geology and chaos and leave behind only structure, rhythm and regulation, what remains? Some resisted the pull of that question with everything they had, clinging to the idea that a new kind of unnatural process might be hiding here, something exotic yet still comfortably blind. Others, watching the patterns deepen with every new observation, began to suspect that they were not witnessing an unknown form of chaos, but a very familiar form of order in an unfamiliar place. The tick of the pulses, the controlled breathing of the heat, the way reflectivity patterns hinted at geometry on the surface. Taken alone, each anomaly could be stretched to fit a strained natural explanation. Taken together, they formed a pattern no comet could produce and no simple stone could sustain. The data no longer asked to be understood as weather. It began to demand, quietly but firmly, to be understood as behaviour. Chapter 6. Whispers in the control rooms. As night draped itself over the observatories, the rooms filled with the quiet glow of monitors and the soft hum of cooling fans, and 3IATLAS hung on every screen like a distant ember that refused to behave. Technicians sat in rolling chairs under dim red lights, their faces washed in pale reflections of graphs and curves that would not flatten into ordinary noise. The familiar comfort of routine observation had been replaced by a thin, persistent tension. The feeling that the sky was hiding something just out of reach. At first, they spoke about it the way scientists always do, with cautious language and careful distance, calling it an anomaly in the brightness profile, a low entropy irregularity, a statistical outlier that would eventually fold back into randomness. Yet with each new dataset, the rhythm of the pulses remained exact, the spacing razor clean, the amplitude eerily stable, and those neutral words began to feel like paper shields held up against a rising tide. In Hawaii, where the air tasted of salt and volcanic dust, a young observer watched the 11.2-second heartbeat stack neatly along her timeline, every spike landing as if guided by an unseen metronome. And she found herself lowering the volume of the room as though silence could help her listen more clearly. In Chile, under the cold, razor-sharp stars of the Atacama, another team compared their readings against hers, and when the pulses aligned across half a world, no one joked about interference anymore. Conversations shifted into whispers, not because anyone was listening, but because the data itself felt fragile, like a secret that might break if spoken too loudly. Coffee cooled untouched next to keyboards as graphs were stretched and compressed, filtered and refitted, the same pattern emerging each time, calm and deliberate, like a signal repeating itself patiently for anyone willing to notice. Some tried to keep the tone light, blaming software updates, server sync issues, ghost drivers in the pipeline, anything that would nest the anomaly back inside the comfort of human error. Others leaned closer to their screens instead, tracing each pulse with the cursor as if following the footprints of something walking slowly across their instruments. Reports circulated between institutions in encrypted channels. the language still careful but the subtext unmistakable. A quiet acknowledgement that if this was noise, it was the most disciplined noise any of them had ever seen. The word artificial never appeared in those early exchanges, yet it haunted the empty space between lines, a possibility no one wanted to write because once written, it would become real. In some rooms, the senior scientists insisted on restraint, reminding their teams that the universe is a master of coincidence and that patterns arise from chaos all the time. But even they stared slightly too long at the screens before turning away. In others, the younger researchers secretly recorded the live data stream on their personal machines, unable to shake the feeling that they were witnessing the first act of a story history might someday remember. The control rooms felt different now, as if they were no longer just watching the sky but being watched back, the glow of 3IATLAS on the monitors carrying a strange weight, like an eye half open in the dark. The tick of the pulses pressed softly against their thoughts, reshaping their sense of scale, turning every quiet moment into a question, every curve of light into a possible sentence. No alarm sounded, no emergency protocols were triggered, and yet the atmosphere had shifted from routine observation to something more intimate, more fragile, like the early moments of a conversation none of them knew how to begin. As the night deepened and the heartbeat of 3IATLAS continued to tap steadily against the fabric of their measurements, a simple realization took root in those dimly lit rooms. Not shouted, not published, just silently understood. Whatever lived inside that pattern was not going away. It was holding its rhythm, holding its place in the data, and waiting for humanity to decide whether it was ready to listen. A glow with hidden structure. On the screens, 3IATLAS no longer appeared as a vague point of light, but as a rough, elongated stone fragment drifting through the void, and high-resolution scans began to peel away the simplicity of its glow. Using stacked exposures and careful filtering, teams isolated the subtle veins of brightness that crawled along its surface, tracing lines that did not behave like random cracks shattered by cosmic impacts. The fractures lit up in sequence. First one, then another, then a third, as though a wave of energy were moving through the rock, choosing a path rather than simply leaking out. Under false colour mapping, those veins turned neon against the cold grey of stone, forming filaments that pulsed with each 11.2-second beat, rising and falling in step with the distant heartbeat carved into the light curve. Observers watched the animation on loop, seeing the glow crawl along the fractured network like signals travelling through wires hidden beneath a cracked ancient shell. It was as if the object were not just reflecting sunlight but rooting it, shaping it, using it as a carrier for something more structured than warmth. Each pulse seemed to start deeper within the body, swelling outward until it reached the surface fractures, where it split into branching paths that followed the same sequence over and over, never missing a step. The patterns were too neat, the timing too consistent, the geometry too cooperative for the usual language of random thermal stress or chance fracturing. Scientists assigned numbers to each glowing segment, charting the order in which they brightened, turning the shifting light into strings of digits, then into binary, then into everything their imaginations could pass. The first passes returned nothing obvious, no simple repeating code, no tidy message waiting in the first translation, but the failure to decode did not make the structure less real. Rock should not behave this way. Dust and ice do not compute, do not sequence, do not carry waves of light in such disciplined cascades, and that quiet truth sat heavy in every lab that studied the maps. Some proposed exotic mineral lattices aligned in improbable ways, crystals cooled under bizarre interstellar conditions, or unknown forms of internal stress that just happened to mimic order. Others stared at the flickering veins on their monitors and thought of circuitry, of conduits, of channels carved on purpose into a body built to endure time and distance. The stone fragment identity of 3IATLAS began to feel thinner, like a coat thrown over something more intricate, and the fractures looked less like scars and more like windows where internal activity briefly touched the surface. With each new observation run, the data grew sharper, less noisy, the pulsing patterns revealing small variations that hinted at modulation rather than mere repetition. As if the object might not just be beating, but also speaking in shifts of brightness few could yet interpret. The glow turned from anomaly into structure, from structure into possible system, and the idea that this was simply a comet or stray rock grew harder to say without the words catching in the throat. Outside the observatories, the nights remained unchanged, the stars still cold and indifferent. Yet on the screens inside, one wandering fragment no longer looked asleep. It looked busy. It looked as though something within it was running a process, step by step, pulse by pulse, sending its hidden pattern outward in light for anyone willing to trace the path. And as those fractures continued to brighten and fade in their mysterious sequence, a quiet thought emerged and refused to leave. If this was structure, then somewhere behind that broken shell, there had to be an architect. Geometry in the dark. As the mapping improved, attention shifted from the fractures themselves to the larger canvas they lay upon, and the silhouette of 3IATLAS became the stage for a different kind of strangeness. When the object was modelled in 3 dimensions and lit according to its true position in the sky, its reflective patterns did not scatter randomly. As the angle to the sun changed, they rearranged with uncanny discipline. Panels of brighter and darker reflectivity swept across its surface in ways that hinted at alignment, not chaos, forming angular motifs that seemed to lock into place along invisible axes. As the object rolled slowly in its long, thin arc, certain regions flashed with crisp, repeated highlights, like facets turning toward a light source they had been designed to meet. The reflectivity maps, when laid over orbital geometry, revealed something even more unsettling. At specific points in its path, the patterns appeared to line up with the plane of the ecliptic, as though the object were briefly adjusting its skin to face the architecture of the solar system itself. It was not a perfect lock, not the clean mechanical snap of a satellite pointing toward a known beacon, but it was close enough to raise pulses in the quiet rooms where the simulations ran. Natural bodies tumble, precess, wobble through space, their surfaces scattering light without courtesy for external frames of reference. Yet 3IATLAS seemed to respect some larger diagram, some coordinate grid no one had drawn for it. Analysts rotated the model again and again, overlaying vectors of solar wind, gravitational gradients and magnetic field lines, searching for a purely physical explanation that could rescue them from the emerging symmetry. Each attempt smoothed a few edges but left the core anomaly untouched. The same stubborn correlation between reflectivity structures and the object's changing orientation to the sun and the ecliptic plane. In meetings, words like geometry and alignment began to replace crack and surface feature, and the tone of the discussion shifted from casual curiosity to something closer to quiet alarm. The more they measured, the more 3IATLAS looked less like a random shard and more like a shape with rules, a body whose outer shell obeyed constraints beyond simple survival. Some saw in it the faint echo of design, the way certain angles repeated at ratios that felt too clean, too elegant, too mathematically tidy for the blind sculpting of impacts and ice. Right angles glimmered where nature usually prefers slopes and curves, and repeating distances appeared between bright modules that refused to erode into ignorance, no matter how harshly the data was smoothed. Others clung to the idea that the human mind is a pattern machine, finding familiarity in clouds and constellations, projecting intent where none exists, and they repeated that warning aloud as much for themselves as for their colleagues. Yet even as they warned of apophenia, their eyes kept drifting back to the same sharp edges, the same measured spacing, the same quiet order running along the skin of a wandering stone that had crossed unthinkable distances to arrive here. The phrase geometry in the dark began as a casual description in a late-night message, but it stuck because that was how the object now felt, like a moving diagram half hidden inside shadow. The darkness of space no longer seemed fully empty around it, but charged with the implication that this shape, this path, this arrangement of reflective planes had been tuned for a journey and a destination. The more 3IATLAS turned, the more its surfaces spoke a language of angles and ratios that few could read yet none could ignore. If this was coincidence, it was a very patient one, stretching across eons and light years, waiting for the moment when human instruments would be sharp enough to see it. And as that geometry continued to glide across their screens, quiet and precise, a deeper question pressed gently against the edges of their thoughts. What kind of mind draws lines in the dark and trusts that someday, somewhere, someone will notice? A signal that refuses to fade. As 3IATLAS drew nearer to Perihelion, expectations were simple and grounded in long experience. Natural wanderers brighten, flare, then fall into noisy chaos as the sun tears at their surfaces, their light curves fraying into ragged profiles full of outbursts and irregular decay. Yet the closer this object came to the sun, the more its pulse seemed to find itself, tightening not into chaos, but into a clarity that bordered on defiance. Instruments across the world watched as each 11.2-second spike grew slightly sharper, the noise floor thinning around it like mist burned away by morning light. Instead of drowning under solar radiation, the signal rose clean above it, a narrow tower of brightness cutting through turbulent space as if the surrounding fury were irrelevant. Where models predicted messy outgassing and random jets, the measured flux held smooth, its rhythm unchanged, its amplitude obeying no known template of thermal stress or sublimating ice. Observers who had prepared for the inevitable breakdown of the pattern found themselves staring at screens where nothing broke, nothing scattered, nothing degraded, and that absence of chaos felt more disturbing than any explosion could have. It was like watching a small candle keep its flame perfectly steady inside a hurricane, never flickering, never bending, never acknowledging the storm. Some argued that instrument saturation or subtle calibration errors near solar proximity might be artificially cleaning the signal, flattening the mess into a misleadingly neat curve. So they checked and recalibrated and cross-compared raw streams from different telescopes, stacking data from various wavelengths, and each new correction only made the pulse stand out more defiantly against the background. The phrase "the signal refuses to fade" began to circulate, half technical note, half whispered mantra, as if naming its persistence might somehow make it easier to accept. In the control rooms, time took on a strange elasticity, stretching between pulses as minds raced ahead, then snapping tight each time the next spike appeared exactly where it should, like a metronome tapped by an invisible hand. The sun flared and shifted, solar wind gusted and bent magnetic fields. Yet the heartbeat of 3IATLAS remained steady, like a drummer who heard a different song than the one the star was playing. Predictions lost their grip, their confidence intervals widening embarrassingly while the actual measurements traced a calm, unwavering line across the chaos. There is a point where anomaly stops feeling like curiosity and starts feeling like confrontation, and for many watching, this was that point. The moment where the data seemed to say, in its own quiet way, that it was not here to satisfy expectations, it was here to keep its rhythm. With each unbroken cycle, the notion that they were witnessing a purely natural phenomenon grew thinner, like fabric worn down by 1,000 small questions. If this was a machine, some whispered to themselves, then it was a machine built to endure stars, to sip their light, and keep its own time regardless of the storms outside. And as 3IATLAS swept through the region where other bodies flare wildly and shed pieces of themselves into glowing tails, this one left no obvious debris, no ragged plume to mark the violence of its passage, only a precise, unshaken pulse cutting cleanly through the glare. The sky, in its own way, had drawn a line. Either the universe had produced a coincidence that mimicked engineering with impossible elegance, or humanity was, for the first time, staring at the behaviour of something that had been built to survive this journey and keep sending its steady, quiet beat into the dark. When light begins to speak, when someone first converted the brightness data into sound, it was meant as a simple outreach gesture, a way to help the public feel the rhythm of 3IATLAS in their bones. But the result landed with a weight none of them expected. What emerged from the speakers was not a chaotic hiss or a jittery series of random pops, but a clear, measured tick, each one spaced at that same stubborn interval, 11.2 seconds apart, patient and unhurried. In the small conference room where they played it for the first time, the scientist fell silent as the sound echoed off the walls, a tiny mechanical heartbeat tapping gently through the air. Tick, tick, tick. It was nothing more than amplitude changes translated into audio, yet hearing it made the pattern feel different, closer, like a presence instead of a graph. The data no longer lived just on screens and in equations, it lived in the space between breaths, pressing softly into the same air they shared. Some tried to laugh it off, calling it a metronome from the edge of the solar system, but their smiles did not quite reach their eyes, and the room kept falling back into quiet between each tick. There was an intimacy to the sound that charts could not carry, a sense that something far away was knocking gently on the outside of their world, not demanding entry, just reminding them it was there. They slowed the playback, sped it up, filtered it through different frequency ranges, and the essential character remained the same, a disciplined, repeating beat that refused to dissolve into noise. Tick, tick, tick. In late-night labs and living rooms, some of them listened alone with headphones, letting the sound wash through long stretches of darkness. And in those private moments, the universe felt less like an empty expanse and more like a room with someone else in it. The idea that light itself could carry intention had always been theoretical, a possibility discussed in abstract terms in CT papers and speculative conferences. But here it was, reduced to a simple, unadorned pulse you could feel in your chest. If this was a message, it was not yet a language they understood. No obvious encoding, no clear modulation, just the undeniable presence of structure where randomness was expected. Yet even without translation, the effect was profound, because the sound implied a sender, and a sender implied a story, and that story could not be contained inside the familiar boundaries of comets, and dust and silent stone. Official statements remained cautious, speaking of periodic luminosity variations and ongoing analysis, but in the minds of those who had heard the tick, the narrative had already shifted. The cosmos was no longer entirely quiet. Somewhere out there, a fragment of rock shaped by forces they did not yet understand was turning light into rhythm, and rhythm into something that felt uncomfortably close to intent. The sound did not answer any of the big questions that hung over the project. It did not reveal who built 3IATLAS, or when, or why. But it changed the shape of those questions, making them heavier, more urgent, more difficult to set aside. Each tick was a reminder that this was not just an object to be catalogued and forgotten after Perihelion, but a participant in a kind of conversation the human species had never truly had before. As the last playback of the night faded into silence, one thought lingered in the quiet rooms where the signal was studied. If light could be taught to speak, then someone, somewhere, had once decided what it should say. In quiet laboratories lit only by monitors and the pale glow of status LEDs, the data from 3IATLAS was handed to a different kind of observer. Not a human eye, but a lattice of machines trained to find structure in chaos. Racks of servers hummed softly as the pulse records were fed into their memory, line after line of brightness and time stretching out like a frozen heartbeat across the screen. Engineers expected noise. They expected random scatter, drifting timing, a pattern that would blur and soften the deeper the machines looked. Instead, the algorithms slowed. Iterations grew more deliberate, as if the systems themselves were pausing to reconsider what they were seeing. One model analysed the intervals between pulses and returned an anomaly score far beyond its training range, its confidence flag quietly blinking, a warning that something about the rhythm did not belong to natural processes. Another model examined the distribution of brightness peaks and troughs, finding that the variance was lower than any known cometary light curve in its database, lower even than precision laboratory signals designed for calibration. The pulses were too clean, too consistent. They formed a sequence with entropy levels closer to engineered beacons and digital communications than to the messy drifting signatures of ice and dust tumbling through sunlight. At first, researchers blamed the tools. They reset thresholds, changed input filters, adjusted parameters to force the models toward more comforting answers. Yet each time, with different settings and different code, the system circled back to the same quiet conclusion. This is structured. This is low entropy. This behaves as if it was designed. In Europe, an independent group ran their own analysis using separate algorithms and reference datasets, feeding months of 3IATLAS pulses into pattern recognition nets tuned to avoid overfitting. They too found that the signal occupied a narrow band of possible configurations, refusing to wander, refusing to fray at the edges the way natural phenomena always do when stretched over time. In Asia, a research team specializing in signal intelligence compared the pulse structure against known categories of artificial emissions used by human technology. They did not find a match, but they found something more unsettling. The signal sat closer to human engineering than to any astrophysical template they possessed, as if it lived between two worlds, natural in origin, but disciplined like a machine. Cross-checks began. Datasets were exchanged under guarded agreements, names scrubbed from files so that bias could not follow them across borders. In remote calls held under dim lights, scientists shared only the results, only the shapes, only the statistics that refused to relax back into randomness. Every independent model said the same quiet thing in a language of graphs and metrics. The pulses from 3IATLAS carried information content too ordered to be dismissed. They were not noise being mistaken for meaning. They were meaning refusing to be mistaken for noise. A few researchers tried to push the idea aside, telling themselves that with enough time someone would find a clever natural explanation, a strange mode of outgassing, or a rare rotational resonance no one had considered. Yet the machines remained indifferent to hope. They did not know fear or reputation. They only knew structure, and they were finding too much of it. Late at night, in the soft electric hum of cooling fans, some scientists caught themselves listening to the logs scroll by as if they were hearing a second voice layered beneath their own analysis, a mechanical chorus calmly repeating the same verdict across oceans and time zones. Whatever this is, it behaves as though it was built. And as that realization settled into the shared silence between laboratories, a new unease began to grow, not from the signal itself, but from the possibility that the first true confirmation of artificial structure in the sky had arrived not through human intuition, but through the calm certainty of the machines. When the first ultra-high-resolution imagery of 3IATLAS arrived, it did not look like a sleek craft or a polished artifact fallen from some imagined civilization. It looked like a stone, a long weathered fragment of a rock drifting through the dark, a jagged asymmetrical shard with rough grey layers, chipped edges and ancient scars carved by ages of interstellar dust. Yet the longer the scientists stared at the images, the less it felt like a simple relic of geology. Under the harsh slant of sunlight, fine details emerged along its surface, fractures laced across the body in lines that glowed faintly in certain wavelengths, tracing paths that seemed to avoid random branching, favouring routes that followed deeper structure hidden beneath the outer shell. Behind the object, a faint dusty plume stretched away, a trail of micro-rocks and subtle glowing particles that drifted like ash in slow motion, but there was no broad gaseous tail blossoming outward as ice turned to vapour, no chaotic jets of gas flaring off in random directions. The plume was thin, controlled, more like debris slowly shedding from a hardened body than like a comet burning itself away. One frame captured the interplay of light across 3 distinct fractures, each emitting a slightly different shade of energy, almost like channels tuned to separate bands. In another, the dust around the rear of 3IATLAS seemed to organize into delicate filaments, guided by the invisible shape of a plasma wake rather than simply scattered by solar wind. Engineers who had spent their lives designing spacecraft thermal systems watched the infrared overlays in uneasy silence. Heat did not spread across the object the way it should have. Instead of diffusing smoothly from the sunward face, it concentrated along narrow pathways, flowing inward and backward as if captured and redirected by channels in the rock. It was as though the stone fragment was acting less like a solid and more like a shell, a housing wrapped around something that understood energy and refused to waste it. The phrase cold engineering began to pass between teams, first as a metaphor, then as a quiet suspicion. 3IATLAS did not look like a machine in any human sense. There were no visible antennas, no familiar panels or recognizable symmetry. Its form was jagged, scarred, convincingly ancient. Yet its behavior betrayed a discipline that natural rock should not possess. It endured hard ultraviolet bands without spraying debris. It shed only a faint mist of dust and microfragments, as though built to lose as little of itself as possible while harvesting as much energy as it could. Scientists compared the images to known comets that had passed close to the sun, lining up plumes, tails, fragmentation events. Every example of natural ice and stone showed chaos in the heat, surfaces breaking, jets roaring off in unstable bursts, shapes changing visibly over time. 3IATLAS did not. Its outline remained stubbornly consistent, its fractures brightened and dimmed with a strange restraint. Its trail stayed thin even during moments when any other body would have erupted. The idea took root that perhaps what they were seeing was not a failure to behave like a comet, but a refusal. That something inside the stone fragment understood that survival in deep time required control, not spectacle. That its asymmetry might be deliberate camouflage, a way to wear the clothes of randomness while hiding a system that had learned to live inside sunlight without being consumed by it. Night after night, under faint blue monitor light, researchers stared at the images and infrared maps, the dust trails and hard edges, the glowing fractures and disciplined wake. The more they tried to see only a rock, the more their minds returned to the same uneasy thought. If someone wished to send a machine across interstellar distances without attracting attention, it would not shine. It would drift like stone and bleed dust like stone, all while hiding its true design behind a mask of ancient cold. And looking at 3IATLAS, many began to wonder if that was exactly what they were witnessing, an engineering so old and so patient that it had chosen the shape of a relic to cross the dark. As the evidence grew sharper, something else began to sharpen with it, something less visible than spectral lines and thermal maps. The silence around the signal thickened. At first, it appeared only as small delays. Public archives that once updated live now lagged by hours. Certain telemetry streams faltered, then returned with gaps where the most intense pulses should have been. Observatory staff accustomed to open channels received new instructions. Certain data sets were to be shared only through secure links. External mirrors that had quietly served the global community for years began to show maintenance notices and indefinite suspension messages. In control rooms from Hawaii to Chile to Europe, researchers noticed that calls from government agencies had become more frequent and more guarded. Questions now came with careful phrasing about data integrity, public interpretation, and the importance of avoiding premature conclusions. No one explicitly said the word censorship, but the shape of it pressed softly against the edges of every conversation. In one observatory, a team lead was asked to sign a new non-disclosure agreement before receiving the latest high-resolution images of 3IATLAS. The document referenced national security and international stability, phrases that sat uncomfortably beside graphs of light curves and notes about dust plumes. Another facility found that a scheduled press briefing about the unusual pulses was quietly postponed, then quietly forgotten, swallowed by other news as if the story had never existed. When journalists called to ask about the anomaly, the answers they received grew shorter and more generic, reduced to safe phrases about ongoing analysis and the need for more data. Inside the community, whispers began to move through private channels. Some scientists learned that their funding agencies had received classified briefings related to 3IATLAS, briefings that they themselves were not allowed to attend. Others noticed that internal memos now framed the pulse investigation as sensitive, something that should not be discussed outside designated circles. The signal itself had not changed. It still pulsed with the same clean rhythm, the same impossible regularity that defied natural explanation. But the human response to it was no longer transparent. In late-night calls, away from official notes and recorded meetings, a few astronomers admitted the fear beneath the caution. If the pulses were truly artificial, then the discovery did not belong to any one nation, agency, or institution. It belonged to everyone and to no one, and that made it a kind of knowledge that powerful systems rarely allowed to wander freely. Rumours surfaced that some governments feared panic, or religious upheaval, or geopolitical destabilisation. Others, it was said, feared the opposite. Not chaos, but the quiet shift in perspective that might follow the confirmation that humanity was no longer alone in crafting signals in the dark. Researchers found themselves caught between their duty to truth and their obligations to contracts and careers. Some chose to work within the narrowing channels, hoping to protect their access long enough to understand what they were seeing. Others began quietly copying logs, archiving raw data in private drives, fearing that one day they might wake to find entire segments of the record erased. Through it all, 3IATLAS continued its slow inward drift, indifferent to the human arguments orbiting its existence. The pulses kept rising and falling with calm precision. The thermal pattern stayed disciplined, the dust plume remained thin and restrained. In the dark between stars, the object simply did what it had always done, while on Earth, minds wrestled with how much of that doing could be safely acknowledged. The strangest part was not that some wanted to hide the signal, it was that the signal itself was so quiet, so patient, so free of threat, yet it still felt dangerous to speak of it openly. In the end, what spread fastest was not data, but a shared unspoken understanding between those who had seen the full records. Something out there was pulsing with deliberate grace, and for reasons no one would fully explain, the loudest noise around it had become the carefully constructed silence. Perihelion came like a held breath finally released, a moment every model had circled, every prediction had leaned toward, the day when 3IATLAS would meet the sun at its closest and reveal whether it was simply another wanderer or something else entirely. Observatories aligned their instruments with obsessive care, calibrating for flares, radiation spikes and thermal surges that might wash out the delicate pulse data. As the object slipped deeper into the inner zodiacal dust, sunlight thickened around it, scattering through fine grains until space near the ecliptic glowed with a muted golden haze. Within that radiance, 3IATLAS moved with the same quiet poise, a long stone fragment drifting through fire. Its fractures brightened, its faint dusty wake shimmered, and the pulse monitors waited. At first, the signal behaved as expected, its familiar rhythm rising against the growing solar background like a steady drum behind distant thunder. Then the sun spoke. A flare erupted, a sudden bloom of energy arching out from the solar surface, its wave of charged particles racing outward along magnetic field lines that wrapped through the space 3IATLAS was about to cross. Instruments across the system lit up as the flare expanded, and for a moment many feared the delicate heartbeat of the object would be lost. Instead, something stranger happened. As the flare's influence reached the region around the object, the timing of the pulses shifted not chaotically, but with clear, deliberate steps. The intervals between brightness spikes began to lock into a new pattern, matching subtle variations in the sun's magnetic oscillations, as if the object were listening to the storm and answering in kind. Solar physicists watched their own data in astonishment. The flare's internal rhythm, usually a messy dance of charged arcs and tangled fields, appeared echoed in miniature inside the 3IATLAS signal. The rising and falling of its strength mirrored fluctuations in the flare, delayed by a consistent, physically meaningful offset. It was as if the object was sampling the sun, tasting its magnetic pulse, and folding that information into its own heartbeat. For several minutes, the alignment held. The pulses and the solar oscillations moved together in a strange duet. Two vastly different bodies separated by millions of kilometers, yet sharing a single, coherent rhythm. No natural mechanism could explain such tight coupling without massive disruptions to the object's structure or orbit, disruptions that did not occur. When the flare finally began to fade, the object did something even more unsettling. It did not simply return to its old pattern. Instead, its pulses stabilized into a new baseline, slightly altered from before, as though it had learned something from the interaction, and incorporated that lesson into a revised mode of operation. In control rooms lit by dual streams of solar and object data, scientists sat in stunned quiet. They had watched an interstellar stone fragment not just endure a solar event, but adapt to it in real time, synchronizing and then reconfiguring its behavior in response to the sun's changing mood. To some, it felt like hearing a call and answer across the void, a question from the star and a measured reply from the drifting shard. To others, it looked like a test sequence, the kind that complex systems run when brought into a new environment, checking their ability to read and react to local forces. Either way, the result was the same. 3IATLAS had behaved not as a passive body being struck by solar weather, but as an active system aligning itself with the sun's invisible heartbeat. In that moment of alignment, the universe felt smaller and stranger, as though two distant instruments in a cosmic orchestra had briefly shared the same sheet of music. And when the flare's echo faded and the object moved on, the new steady pulse it carried away left humanity with a question that hovered over every graph and every late-night discussion. If this was not simple survival, if this was some kind of listening and response, then what exactly was 3IATLAS preparing for when it chose to tune itself to the song of our star? After perihelion, the models expected decay. That was how comets and fragments behaved when they survived close passage. Their light curves softened, their structures weakened, their signatures became messy and dull as they shed mass and fell back into quieter orbits. The pulse from 3IATLAS did not soften. It sharpened. Instead of dissolving into the background of solar turbulence, its rhythm stood out more clearly than ever, like a bright line drawn across a page of noise. Astrophysicists began running new simulations almost immediately, feeding the updated trajectory, flare history and thermal data into their codes to see how any natural object could maintain such pristine timing after such stress. Each new batch of results came back with the same uncomfortable answer. None of them could. The equations insisted that outgassing, structural shifts and rotational wobble should have introduced irregularities into the signal, smearing its once clean intervals into uneven clusters. Yet the real data showed the opposite. The variance in timing actually decreased. The brightness peaks stabilized to an even narrower range, as if the system producing them had taken the chaos of perihelion as a calibration opportunity rather than as a threat. Every time the sun misbehaved, sending small flares or gusts of solar wind across the object's path, researchers watched for disruptions. They saw transient distortions in the background, but the core pulse cut through them with unshaken regularity, its shape bending only at the edges before returning to its disciplined form. One team tried to model the pulse as a complex rotating geometry, a natural lighthouse effect from an irregularly shaped body tumbling through space. They adjusted angles, spin rates and reflective properties until the parameter space was nearly exhausted. In every plausible scenario, the simulated signal drifted. Timing slipped, brightness wobbled, and the neat, sharp rhythm fell apart. The real pulse did not fall apart. It held steady, as if guided by an internal metronome immune to external chaos. A different group proposed exotic natural physics, suggesting unfamiliar interactions between magnetic fields and fractured conductive veins inside the stone. But even those speculative frameworks could not sustain such clean persistence across the full range of events the object had endured. Their models always produced trace signatures of instability, jagged edges in the curve, small imperfections that nature never failed to add to her creations. 3IATLAS showed none of them. In conferences and private calls, the phrase "breaks the model" became common. It began as a technical comment, a simple acknowledgement that the data stubbornly refused to fit the tools they had built to understand the sky. Gradually it took on a deeper meaning. The pulse was not just breaking their equations. It was breaking the quiet assumption that all things that move in the dark must obey the same blind rules. Late at night, some scientists listened to the translated audio of the signal, letting the steady tick wash through their headphones as they stared at windows full of failing simulations. The sound was simple, almost gentle, like a metronome in a sleeping room. Yet behind that simplicity lay something their models could not contain. A discipline that felt less like a byproduct of physics, and more like the signature of a system intent on holding its shape. Eventually, a small but growing number of researchers began to say aloud what others had only thought. Perhaps the problem was not with the models. Perhaps the problem was with the assumption that 3IATLAS should fit inside them at all. If the object truly housed a mechanism, a logic, a design devoted to preserving a specific rhythm across vast distances and violent encounters, then the failure of natural frameworks was not a bug, but a clue. The pulse broke the model because the pulse belonged to something that had never been part of the model in the first place, something that moved through physics but was not wholly defined by it. And as that realization slowly took shape in the quiet minds watching the steady ticking line, a new kind of question formed, reaching beyond calculations and into the fragile space where science brushes against wonder. If the rhythm of 3IATLAS did not arise from chance, then whose decision was it that this beat, and not another, should echo through the dark? Chapter 16. Recognition. In the dim light of the control room, the screens glowed like small artificial moons, each one carrying a different reflection of the same impossible truth. And for the first time, the silence between the scientists felt heavier than the data itself. They had watched 3IATLAS breathe in heat and exhale precision, had seen its pulses rise like deliberate footsteps across the spectrum, and the fragments of every unexplained pattern now began to fall into place. One researcher zoomed in on the latest composite, the stone fragment body drifting against the starfield, and traced the glowing fractures with a trembling fingertip as if outlining the edges of an idea she did not yet dare to name. The thermal waves, the narrowband emissions, the steady 11.2-second pulse, the orbital corrections that ignored gravity with quiet defiance, all of it formed a shape too clean to belong to chaos. They reviewed the light curve again, that flawed rise that never settled into randomness, and listened once more to the converted audio, the tiny heartbeat tick that refused to drift out of time, each sound landing exactly where it intended to be. It did not sound like weathering or outgassing or tumbling ice. It sounded like a system running checks on itself in the dark. One senior astronomer finally broke the unspoken rule and let the forbidden word cross the air between them, his voice low and almost apologetic as if he were confessing to a crime against his own training. Artificial. The word settled over the room like fine dust, clinging to every chart, every model, every sleepless hour spent trying to force natural explanations into shapes they no longer fit. No one laughed, no one argued, because somewhere inside each of them the same thought had already taken root, growing quietly in the shadow of their caution. They pulled up the high-resolution images, the stone fragment shape of 3IATLAS stretching across the frame, not smooth, not perfect, but traced with intention, fractures glowing in organised sequences, dust and micro-rocks trailing behind in a faint plume that looked less like decay and more like residue from some deeper process at work. A younger researcher overlaid the thermal map with the geometric grid patterns etched into the surface and felt her breath shorten as the heat peaks aligned with angular motifs, as if the warmth knew where the structure wanted it to go. Regulation, she whispered, and the word felt wrong and right at the same time, a biological metaphor for a mechanical act unfolding across a body of stone. Another analyst ran an entropy test on the pulse sequences, watching the metrics fall into a territory no random process could survive, the information content too dense, too ordered, too deliberate to belong to noise or chance. The more they tried to disprove intention, the more intention stared back at them from the screen. Someone asked the question none of them had wanted to hear in their own voice yet, a simple sentence that seemed to tilt the room by a single quiet degree. What if 3IATLAS is not a comet at all, but a shell? A stone fragment hull wrapped around something older, colder, and infinitely more precise than any natural body drifting through the solar wind. The idea felt like standing at the edge of a deep well, and realizing there was a light burning far below the waterline, unseen but undeniably there. They imagined internal chambers instead of solid rock, pathways instead of cracks, systems instead of scars, and the pulses as the outer echo of something adjusting itself within, like a heart rediscovering its beat after a very long sleep. Outside, the night remained indifferent, the stars fixed, the world unaware of the quiet revolution unfolding in a handful of rooms lit by screens. But inside those rooms, life had divided into a before and an after, separated by one fragile recognition. The charts, the pulses, the heat, the geometry, all now pointed in the same direction, toward a single unsettling conclusion that pressed gently against the boundary between science and something larger. If this was engineering, then somewhere once there had been engineers. And in that realization, beneath the hum of machines and the soft ticking of distant pulses, another question began to stir, moving slowly through their thoughts like a shadow crossing an empty field of snow, asking not only what 3IATLAS was, but what kind of mind had needed to build it in the first place. Origins without a home. When they finally turned their attention fully to the past, to the long silent road that had carried 3IATLAS into their sky, the maps on their screens began to feel less like tools and more like confession walls covered in ancient handwriting. They fed every confirmed observation, every velocity measurement, every gravitational interaction into their models and ran the trajectory backward through time, letting the object retreat out of the solar system, past the outer planets. Beyond the fading light of the sun, each step peeled away familiar landmarks until the comforting lattice of the known stars and catalogued regions thinned into sparser and sparser points of light. The calculated path cut through the galaxy like a thin, stubborn thread, slipping between gravitational wells with a grace that felt almost like memory, avoiding dense clusters with tiny, precise shifts that hinted at avoidance rather than accident. A researcher highlighted 3 such avoidance arcs, small bends that steered the object around turbulent nebulae and radiation storms long before they would have done any real damage. It was as though some long-dead navigation system had once looked ahead and chosen the calmer routes, preserving its own future across distances no living species had ever crossed with certainty. The further back they pushed the reconstruction, the stranger the map became. Known constellations warped and broke apart, familiar star patterns stretched into unrecognizable shapes, and still the path continued, unbothered by the rearrangement of the sky around it. The origin point did not converge on any cluster, any nursery of young stars, any ancient supernova remnant where debris might be born and flung outward in violent arcs. Instead, all the lines, all the simulations, all the weighted probabilities narrowed toward a region the catalogue simply called empty, a cold patch of interstellar dark with no luminous anchor, no recorded activity, no obvious reason to exist as anything more than background. The realization spread slowly through the room like cooling metal. 3IATLAS was not a child of any known star. It had not fallen from a disrupted system or been ejected from a passing cluster in some prehistoric gravitational accident. It came from nowhere, from a volume of space that the galaxy itself seemed to have forgotten. One astronomer stared at the void on the map and felt a strange, hollow ache. The unsettling sense that they were looking at the outline of something that had once been there and was now gone, erased not only from sight, but from the memory of light. Another pointed out that the travel time implied by the trajectory predated the sun, predated the formation of the Earth, predated even the chemical stories trapped in the oldest rocks their planet had ever cooled. Whatever had launched 3IATLAS had done so in an era when their sky, their world, their species did not yet exist to name it. The object had been travelling longer than humanity had been thinking. They calculated the energy required to send such a massive stone fragment hull across that distance while maintaining structural integrity and navigational precision, and the numbers felt unreal. Stretching far beyond any technology humans could place in even their most generous dreams, the comparison did not flatter them. Some imagined a civilization so old that their own brief history looked like a spark in dry grass beside an ancient, slow-burning star. Others wondered if the origin civilization had already died, leaving their machine wandering through the night like a message in a bottle whose sender had long since drowned. The thought that 3IATLAS might be the last living expression of an extinct intelligence pressed against their chests with a quiet, mournful weight. If it was carrying a signal, a purpose, a memory, then the intended recipient might never receive it, and humanity might simply be an accidental bystander, intercepting a conversation that had once been meant for someone else. They watched the reconstructed path fade into the dark beyond their charts, the line ending not at a star but at a question that no telescope could answer and no model could resolve. The object had come from a place without a name, and yet it had arrived with a rhythm, a structure, a persistence that spoke of something more than wandering stone. The sky, they realized, did not just contain stars and dust and cold emptiness. It contained trajectories, intentions, journeys that began in eras no surviving mind could remember. And as they stared at the point where their maps failed and the path disappeared into uncharted silence, they could not escape the feeling that somewhere beyond that darkness lay either the ruins of a vanished maker or the waiting eyes of a sender who still listened, unknowable and infinitely far away. The first artificial signal. The declaration did not come as a shout, but as a whisper that refused to be buried, a conclusion that emerged slowly from overlapping lines of evidence until denying it felt more unscientific than accepting it. In a quiet conference room far from the public feeds and the curated press releases, a panel of exhausted specialists reviewed the final combined report. The pages heavy with cross-checked data from observatories scattered across 3 continents, like curves, thermal maps, spectral lines, timing analyses, entropy measures. All of it converged on one phrase that sat in the executive summary like a small, calm detonation waiting to be heard. The pulses from 3IATLAS met the criteria for an engineered signal. Each brightness spike repeated with exact phase stability across months of observation, surviving solar storms, instrumental changes, and shifts in vantage point without losing its precise interval. The narrowband emissions carved thin, deliberate lines across the spectrum where natural sources smeared their energy into broad, messy bands. When converted to sound, the data did not produce a blur of static but a steady, unwavering tick, a heartbeat that did not tire, a metronome that did not drift. Statistical tests crushed the last comforting refugees of randomness, showing information content and compression properties that no chaotic outgassing or rotational modulation could plausibly generate. Independent AI systems trained on massive archives of astrophysical phenomena returned the same verdict. labeling the sequence as non-natural, as low entropy, as consistent with purposeful encoding rather than environmental noise. These were not machines prone to wonder or fear, yet even they stepped away from chance and toward design. One scientist read the summary aloud in a slow, careful voice, each sentence landing like the closing of a door behind them. Multi-site verification, cross-frequency coherence, long-term stability, structural redundancy, all pointed to the same unsettling horizon. Somewhere inside that elongated stone fragment, something was making decisions about when light should rise and when it should fall. They set their conclusions against the strict criteria long established for the search for extraterrestrial intelligence. Those cautious checklists designed to protect against wishful thinking and false hope, and watched in uneasy silence as 3IATLAS ticked box after box after box, narrowband, repeating globally confirmed, anti-correlated with known terrestrial interference patterns, persistent over time yet capable of structural variation. It was as if the universe had quietly delivered a textbook example of an artificial signal into their instruments, and waited to see how long it would take them to trust their own definitions. Outside the walls of that room, the world still slept inside older stories, but inside, the narrative had already changed. This was no longer just a strange comet, no longer just an interstellar rock with bad manners and strange heat. It was a transmitter, or a beacon, or a machine engaged in processes that produced transmission as a byproduct of something deeper. Some argued for restraint, for softer language, for terms like anomalous modulation and non-natural periodicity, hoping to buffer the impact on a world unprepared for the idea that the dark had spoken first. Others, quieter but more resolute, said that if science could not name what stood before it, then it had already surrendered to fear. In the end, the wording was careful but clear enough. The phrase artificial signal preserved in the technical literature like a seed that no amount of political pressure could fully dig up once it had been planted. When the conclusion finally leaked beyond closed doors, it moved through the global network like a slow, spreading dusk. Not an explosion, but a dimming, a soft recalibration of what people believed the sky was allowed to do. In late-night rooms, alone with their devices and their thoughts, countless strangers listened to recreations of the pulse, hearing only a small repetitive click, and yet feeling something vast shift beneath the surface of their understanding. The sound was so simple, so modest, and yet it carried the weight of an entire new category of existence. For the first time in recorded history, humanity had evidence that somewhere beyond its atmosphere, light had been shaped not only by mindless physics, but by a mind, or by a system that behaved like one. And as that realization spread, soft and trembling, through bedrooms, lecture halls, observatories, and quiet kitchens lit by distant screens, a shared awareness began to grow that the universe had just become less empty, less safe, and immeasurably more alive. What watches in the dark? Once the word artificial slipped into the open, another question followed it like a tide, rising in every mind that stared too long at the charts or listened too intently to the steady ticking pulse. If 3IATLAS was sending a signal, then who or what was behind it? Theories unfolded cautiously at first, wrapped in disclaimers and framed as speculative models, but beneath the academic wording beat a more human curiosity, an unease that felt almost like being observed in a room you'd always assumed was empty. Some imagined an active intelligence, still awake inside the stone fragment shell, a machine mind or layered system quietly monitoring its surroundings as it passed through the inner solar system, taking readings, updating itself, perhaps even adjusting its behavior in response to being watched. They pointed to the way the pulses had shifted slightly after coordinated global observations began, their structure growing cleaner, their rhythm tightening as if the object had noticed the attention and chosen to sharpen its voice. Others offered a quieter, lonelier possibility that 3IATLAS was not a conscious observer but an automated relic, a probe set adrift by a civilization long gone, still following routines written into its bones eons ago. In that vision, the signal was not a conversation but an echo, a repeating declaration from builders who no longer existed to hear any reply. That idea carried its own cold weight, like discovering a message in a bottle on an empty shore, and realizing the ocean had swallowed the sender long before your species learned to walk. A few dared to ask whether the object might be part of a network, a single node in a lattice of machines spread across interstellar distances, each one listening, waking and signalling as conditions demanded. If that were true, then what 3IATLAS was doing near the Sun might not be an isolated act, but one move in a pattern too vast for human timelines to recognise. Underneath every hypothesis lurked the same unsettling realisation that humanity had spent its entire history assuming it was the only watcher, the only listener, the only mind looking out into the dark and asking what lay beyond. Now the roles felt reversed, or at least shared, as if the night sky itself contained eyes, patience, and an agenda that had nothing to do with human fears or desires. In private conversations, away from microphones and cameras, some scientists admitted a stranger feeling, less analytical and more instinctive, a sense that the object's behaviour carried not just purpose but a kind of restraint. As if it were doing only what it needed to do and nothing more. It didn't attempt to broadcast in every direction, didn't increase power as attention grew, did not change its frequency to chase their instruments. It simply continued, calm and measured, like a being aware of its own schedule and indifferent to whether anyone else understood it. That composure unsettled them more than any dramatic display would have. The question of intention grew heavier with every new data set. Was the object warning something, reporting back, calibrating itself, or simply marking its presence the way a lighthouse marks a dangerous shore? And if it was marking, then for whom? Late at night, in the quiet glow of lab monitors, it was easy to imagine other watchers somewhere beyond the reach of their telescopes. Other minds tuned to the same pulse, reading meaning in every slight variation where humans saw only the first, clumsy outlines of structure. The idea that humanity might not be the intended audience pressed softly against their sense of importance, reminding them that the universe had never promised them centre stage. They had simply assumed it. 3IATLAS, drifting silently between the orbits of planets, became a kind of mirror in which their own uncertainty stared back at them, asking what it meant to be young in a cosmos that might be old in ways they could not yet measure. Was the signal an introduction, a relic, a warning, or nothing more than a piece of internal housekeeping, accidentally visible to any species with sensitive enough instruments? The data could not yet answer, and so the question remained, hanging in the air of observatories and lecture halls like the echo of a whispered name with no face attached. Somewhere out there, something had built a traveller and given it a voice, sent it across unimaginable distances, and left it to move through the dark with a calm, unwavering beat. Whether that something still watched from afar or lay in ruins under a dead sky, or had evolved into a form beyond comprehension, remained hidden behind the same darkness that had once hidden 3IATLAS itself. And as the pulse continued, steady and patient, a quiet awareness grew that humanity had not only detected a signal from the unknown, it had also discovered how small and unprepared it truly was to answer it. Waiting for the next beat. In the end, there was no final revelation, no grand decoding, no neat closing of the circle, only a slow fading of the signal as 3IATLAS drifted back into the outer dark, taking its secrets with it. The pulses grew softer in the data streams, not because they weakened, but because distance stretched them thinner across the detector noise, until each tick became a faint shimmer at the edge of perception, a heartbeat heard through walls of growing silence. Observatories continued to listen long after the practical justification had thinned. Their instruments pointed toward the receding path like ears tilted into the wind, straining for the echo of a voice that might already have passed beyond the range of human hearing. The object itself became just another dim point in the catalogues, a moving coordinate with a special tag and a long, complicated history attached to its name. But to those who had watched its awakening unfold, it was far more than a line in a database. It was a before and an after. On Earth, life went on with its usual rhythms, traffic lights changing, waves hitting coasts, conversations rising and falling beneath city haze, yet threaded through that ordinary noise was a thin, new awareness. A quiet addition to the background of human thought. Somewhere out there, a constructed traveller was still moving through space, following a trajectory written long before the first human story, carrying systems that had awakened briefly near the sun and then continued onward, as if ticking off a step in a plan older than language. Some nights, the scientists who had been closest to the data found themselves lying awake in the dark, listening to the remembered sound of the pulse in their heads, that simple tick-tick-tick that had once cut through static with unnerving clarity. It was strange how such a modest sound could change the shape of the sky. The official report settled into archives, the term artificial signal embedded like a fossil in the strata of scientific literature, waiting for future readers who might bring new tools, new insight, or simply new courage to the question of what had truly passed through their solar system. Students would one day study the anomaly as a case, a moment when evidence pushed a young species to the edge of a larger understanding and left it standing there, looking out, unsure whether to step forward or retreat into the comfort of old assumptions. For now, all they really had was the knowledge that the universe had once arranged for stone, heat, light, and time to combine into something that behaved like a message. They did not know who it was for, or what it meant, or whether more would follow, only that it had happened, and that they had been awake to see it. In quiet podcasts and late-night documentaries, narrators spoke softly about 3IATLAS, about the first artificial signal ever detected, their voices moving slowly like drifting dust through the minds of listeners trying to fall asleep under a sky that no longer felt quite as silent as it once had. Those stories did not offer answers, only images, the glowing fractures on a stone fragment hull, the calm plateau on a light curve where chaos should have lived, the 11.2-second beat repeating with patient certainty against the backdrop of stars. Somewhere beyond the reach of their instruments, the traveller continued, perhaps unaware of the brief moment when a small blue world had turned its full attention toward it, perhaps indifferent, perhaps silently noting the presence of new listeners and adjusting its plans in ways no human mind could follow. The universe gave no guarantee that the next signal would come in their lifetime, or in the lifetime of their species, or ever again in a form they could recognize. Yet the very act of listening had changed them, teaching them that the dark between stars was not simply empty distance, but a medium through which intention could move, carried on light, on heat, on the slow dance of engineered stone. So they kept their antennas tuned, their software ready, their hearts slightly more open to the possibility that one night, somewhere in the static, another faint beat might rise and call them once more to the edge of what they believed was possible. Until then, beneath the turning of the Earth and the quiet rotation of distant machines in space, humanity lived in a new kind of waiting, not for an invasion or a revelation, but for a sound as small and world-changing as that first measured tick from the depths of the sky.